Hello, and welcome to Math with Asna. In this lesson, we're going to talk about pairs of angles. We'll introduce different types of angle pairs. We'll learn the definition of each one, how to identify them, and how to use them in problems. Congruent angles. Now, we've talked about congruent segments. We can also have congruent angles, and these are angles that have the same measure. Now, for the notation, we would name the angle, so there's no M here. Angle ABD is congruent to angle GHF. If we were talking about their measures, if I wanted to say the measures are equal, I would say the measure of angle ABD with the M is equal to the measure of angle GHF. So notice the difference between naming the angles in terms of their congruence and naming them in terms of their equality. Complementary angles are angles whose measures add to 90 degrees. Supplementary angles whose measures add to 180 degrees. Adjacent angles. These are angles that are right next to each other, so they share one side. So if I've got two angles here, I've got one angle and I have another angle, and they share this side and this vertex. Those are called adjacent angles. A linear pair are two angles that are both adjacent and supplementary. Now, one of the only things that you're allowed to assume in geometry is that a line is straight if it looks straight. So if I've got a straight line and then another angle, these two angles are adjacent. They form a straight line, which means they have to be supplementary. And the last thing, vertical angles. Two angles are vertical angles if their sides form two pairs of opposite rays. Essentially, for vertical angles, you're looking at an X. So if I draw two lines that are intersecting, I've got this angle and this angle right across from each other. These are vertical angles, and these are vertical angles. So you will always have two sets of vertical angles. Linear pair postulate says that two angles that form a linear pair are supplementary. It's also really similar to the definition of a linear pair. Vertical angles theorem, vertical angles are congruent. So anytime you have vertical angles, you know that they are congruent. Let's name these angles. Complementary angles. Now, I know that CDF is a right angle because I see that box. I also know that FDA is a straight line because that's what I can assume in geometry. That means that this is also going to be a right angle. So complementary angles would be the angles that form this right angle. So the two angles that would give you that 90 degrees would be CDB and BDA. So I'm going to say angle CDB and angle BDA. Supplementary angles. Now there's actually a few that you could choose from. I'm just going to go ahead and pick this as my line, and I'm going to say that this forms my supplementary angle. So FDE, EDA give me supplementary angles. Adjacent angles. Now you're looking for angles that have a common side. So again, there's lots of different options here. I'm going to go with angle FDC and angle CDB. A linear pair. Angles that are both adjacent and supplementary. So you can have complementary angles and supplementary angles that are not adjacent. That's fine. A linear pair has to be both adjacent and supplementary. I've actually already used one linear pair, but just to be different, I'll go with another one. I'll say FDB and BDA. That's another linear pair. Angle FDB and angle BDA. All right, vertical angles. Now be really careful with this one. A lot of times we'll say vertical angles like this. This is a common mistake. So we'll say this angle and this angle are vertical angles. No, that's not true. And the reason they're not true is because I'm using way too many lines here. Vertical angles are formed by two lines. This one I've got 1, 2, 3, too many. So what I need to do is look at where I'm making an X. I'm making an X right here. FDA all right? The line that has those points and the line that has these points. That makes an X. So my vertical angles would be angle FDE and angle BDA. And now you can have more vertical angles, but that's just the one that I chose. All right, our first example. The measure of angle DHT equals 100, such that it forms a linear pair with THE. What is the measure of THE? Well, I know that a linear pair has angles that are adjacent and supplementary, so they have to add up to 180 degrees, which means if this angle is 100 degrees, the only way to get this angle to be supplementary is if it equals 80 degrees. 100 degrees plus 80 degrees is going to equal 180, therefore making them supplementary. Angle 1 is complementary to angle 2. All right, I'm going to start out by just using that. So measure of angle 1 plus the measure of angle 2 equals 90 because they're complementary. All right, such that the measure of angle 1 is 3 plus twice the measure of angle 2. Okay, let's write that down. The measure of angle 1 is equals 3 plus twice the measure of angle 2. This is essentially a system of equations. I can substitute this value of the measure of angle 1 into that equation. So what I'm going to do is replace measure of angle 1 with what I just wrote. So 3 plus 2 times the measure of angle 2. And then the rest would stay the same. So I substituted. Now, if you wanted to use a variable instead of using measure of angle 2, that's totally fine. I just like to keep it. So I'm going to treat it like a variable. So 2 measure of angle 2 plus 1 measure of angle 2 gives me 3 measure of angle 2. And I'm going to subtract 3 on both sides. And then I'm going to divide by 3. So I get the measure of angle 2 equals 29 degrees. Now to find the measure of angle 1, got a couple options here. I can substitute it into this and solve that way. Or I can say, well, if they're complementary, they have to add up to 90. So the measure of angle 1 has to be 90 minus 29 degrees, which is going to give me 61 degrees. So the measure of angle 1 is 61 degrees. The measure of angle 2 is 29 degrees. Okay, we want to use the diagram to solve for x. I can see that these are vertical angles because they are formed by an x, which means that they are congruent because my vertical angles theorem says that they're congruent. And if they're congruent, I can set them equal to each other. So half x minus 3 equals 27. And add 3 to both sides. And multiply everything by 2. So I get x equals 60. If you learned something, please like and subscribe and stay tuned for more videos.